Continuation of the previous lesson where we were starting to name ionic compounds and write formulas. So in this lesson we're going to look at the names of ionic compounds and write out the formulas. And we're going to look at the formulas and write out the names. So as you can see, this is going to get a lot more difficult real fast. This is normally where students start to look at this and realize this is going to be a lot harder than they at first thought. So let's go ahead and get started here. We have some names of ionic compounds. I generally like to start with the anions. So we see bromide here, and that comes from bromine, which is a Br. If I don't know that, I can just go back and look at the periodic table. And normally when you're in class doing this sort of worksheet, you have your periodic table handy. And I see bromine right here. This is a halogen. These are group 7 elements. All of these typically gain electrons, so they have -1 charges. So I know anything in this group is going to be -1. I'll put my -1 here. Let's go to the cation. What in the world? That's what some kids think when they look at this. Ammonium. They're like, what the? There's no ammonium on the periodic table. Well, if you don't know where it's at on the periodic table, that means it's probably a polyatomic ion. So if I look over here on my list, I see that ammonium is actually NH4. It's a +1 cation. There's only a few polyatomic cations. Most of them have negative charges. So NH4, that's what throws people, because most of these are always at the end of the ionic compound. NH4 +1. Let's go put her down here. Well, now I'm in a good spot because I see that this is a +1, this is a -1. I can just go ahead and write out this formula as NH4 Br. Notice I don't have any charges on here because it is neutral. Go down to the next one, nitrate. Yet again, a polyatomic ion that I need to memorize, NO3. Nitrite is NO2. Nitrate, NO3 -1. Let's put that down, NO3 -1. And when I see the Roman numerals here, I already know automatically this is a +3. In fact, on a test or a quiz, just put down the charges that you know. And write out the polyatomic ion if I know it in the charge right away. So this is a +3, nickels Ni. And remember, transition metals can have different charges. They can have different oxidation states. Nickel might sometimes lose 1 electron. Then it would be +1 nickel. Sometimes it would lose 2, sometimes 3. It depends. That's why we have to put down the Roman numerals so we know what we're talking about. So nickel is a +3. Let's put the 3 charge here. And nitrate is a -1. Well, I see the problem here. I'm going to have 3 of these to equal 1 of these. Don't look at these numbers down here. Look at the charges. People always make that mistake. They start looking at these numbers here and get all confused. Just look at the charges. So I need 3 nitrates. NO3, 3. This means I have 3 nitrates, and they're all -1. And I will put 1 nickel here, which is a +3. Going down, phosphate. This is PO4. So let's go ahead and put it here, PO4. And it's a -3 charge. It's on the chart over here that we have to memorize. Aluminum. Well, where's aluminum? Let's go check it out. Aluminum is in group 3. Here it is. So it's going to be a +3. Now sometimes people put a Roman numeral by this, but pretty much everything in here is normally going to be a +3, but there are a few exceptions, but they're just not common. So we normally know aluminum is going to be a +3, so let's go back. I know aluminum is a +3, this is a -3. So yet again, I'm in a good spot. These are -3, +3, aluminum. phosphate. Now over here, I have sulfite. Yet again, I know sulfate is SO4. Sulfite is SO3, -2 charge. It's on the table if we needed to look at it. Potassium. Potassium is K. Let's go look at the periodic table. Here's potassium. Well, just remember everything here is a +1. Alkali metals are +1. Alkaline earth metals are +2. These here never need Roman numerals. I've seen students do that where they start putting Roman numerals for these. We always know these are +1. We always know these are +2. Hence, we don't need the Roman numerals. So this is going to be a +1. And now I go ahead and look at this. Well, yet again, we have 2 of these and we only have 1 of these. So I'm going to have to double this. 2K, 2SO3. This is starting to make some sense. It seems logical. Carbonate, yet again, if I don't know it, look it up. CO3, 2 minus, -2. Let's go ahead and put it down. CO3, -2. Sodium, Na. Yet again, if you don't know it, go back to your list. Yet again, it is a group 1 element +1. This is starting to go faster. See how chemistry can be fun when you know what you're doing? Yet again, we have a -2 charge here. We only have a +1, so I'm going to have to double this. Na2CO3. Magnesium nitrate. Well, we did nitrate up here already. So we have NO3 -1. And magnesium. Let's go check out our periodic table. Here we have magnesium +2. Alkaline earth metal. So Mg +2. Well, I have to double this. This is where people get confused sometimes. When they go to double these polyatomic ions, they start to they think I need 2 of these, but then they take their little 2 and they multiply it with this, and they start thinking about what they should do with this number here. As I've said before, you can never change the amounts of oxygens on here. If you start changing these, you're changing the polyatomic ion, you're changing the structure of it. So just forget about it. Don't mess with that. Just go over here and write out NO3, put it in parentheses, and write out your 2. And then we're good to go. Sulfide. Remember, if it's an ide, it has no oxygen. That's just an S. We go look at our periodic table. And I've also seen people make this mistake. They have some assumption that if it's an ide, it's just a -1, no matter where it's at. It depends on the group it's in. Remember, halogens are -1, chalcogens are -2. We have -3. So here's sulfur. So it has to be a -2 charge. I know this is going to be -2. Luckily, I already know, yet again, there's a Roman numeral. This iron has to be +2. So that's Fe +2. I got lucky. They canceled out. So this is just FeS. Going down. Don't get confused with oxide. That's just oxygen. That's O. O is also a -2. This is a copper 1 though. So this has to be a +1. Cu +1. Well, I'm going to need 2 of these though. Alright, I need 2 copper 1s. Cu 2 O. Copper oxide. Phosphite. PO3 -3. Notice I have phosphate -3. If I lose one oxygen, I have phosphite, PO3 -3. The charge stays the same. And manganese. Well, remember, manganese is different than magnesium. Those are easy to get confused. Manganese, it's a transition metal because it has a 2 here. I know it has a +2 charge, so let's go to the periodic table. Here's manganese right here, 25. This is magnesium. So it's a transition metal right here, Mn. Let's go ahead and put down Mn. I already know it's a +2. Here's my +2. Now, this is kind of confusing. I can't easily just make one of these more than the other one. I have a -3, I have a 2. Well, this is where we can do the crisscross rule. If you remember about that, I can take this 3 and put it down here. So, Mn 3. I can take the 2, and yet again, do not get confused. People think, oh wow, the 2 is going to go down here. Okay, so it's going to replace this 3, or I got to multiply it or do something weird with it. Like I said, forget the oxygens. Just leave them alone. PO3, but now I got 2 of them. Well, let's quickly see if this makes sense. I have 2 -3 charges. This is all -6. I have 3 + 2 charges. That's +6. It cancels out. Okay, last one. Acetate. This is one that always gets people. Acetate. Check this out. C2H3O2 -1. Wow. I got to memorize that? Well, it's not too bad. Just think it's 232. C2H3O2. Let's put it here. C2H3O2. Note it's a -1 charge. Well, I already know this copper is a +2 because it's copper 2. Well, I'm going to need 2 of these acetates apparently. So put my copper, put my acetate C2H3O2, 2. All right, no problem. So it looks like we're making progress here. We've learned a few things of what we should do and not do. Really what we need to do is memorize some of these polyatomic ions. But when you're first starting out, just keep a little sheet of your polyatomic ions near you so you can refer back to it and slowly try to memorize the ones that are important that you see a lot. Also, keep in mind some of the first cations can be polyatomic, the most common one being ammonium, which really throws people off. We've also learned that if it has a Roman numeral, just quickly write down the charge so we know what it is. And we've also know that if there is a polyatomic anion, go ahead and check out the charge really fast, and then we could put it together and write the formula. So I hope that helps. In the next short video, I will do this worksheet, and then we'll see where we're at. And if we have to do some more practice, we will do a few more worksheets. The best thing to do to learn all of this is, honestly, do about 5 or 6 of these a day. Just find a worksheet with 20 or 30 of these on there, and every day do a few of them to keep refreshing your memory over and over and over. And it really, really helps. I think a lot of students, when they're in class, they just look at this, they do a few worksheets, they think, oh, I have it, I'm good. I don't have to study it anymore. And then when they get more complicated ones, they miss them. So it's like anything in life, you got to practice it. So I hope this helped a little bit, and we'll do a few more videos later on to reinforce all of this.